All right, welcome back to our next video in the series. This is the second array list video. I would make sure you watch the first video where we talked about what an array list is, what's the basic syntax for declaring an array list, and what are some methods that you would use. In this video, I want to talk about a few more of these methods that you might talk about. We're going to contrast arrays and array lists. What are the advantages? What are the disadvantages? And then we need to understand what the wrapper classes are and the concept of boxing and unboxing. So to start with, I've made a array list right here, and it is full of the first 4 words of Lincoln's famous speech, right? 4 and 7. And when I go to try to print out this particular array list, we get a nice 2-stringed array list. Looks really good. All right, so maybe I have some questions about these particular elements, what's going on in here. The methods I want to talk about are contains, indexOf, and lastIndexOf. So for instance, I could say, hey, words, do you contains, and then it's looking for the type of object that we put in there. Do you contain the element score? Is score in there? And I go to print that out, and it says true. But if I said 4 and 7 years is not in the list, I go to print that out, it says false. So I can go looking and see if the same element appears, if dot equals returns true after looking through all the elements. So that's one option. I could say, all right, what is going to be the index of, and let's say I go looking for the word 7. Index of 7, I go to print that out, and it says 3. If I go 4 and 7 years, I go looking for an element that's not there. We get -1, right? Usually when we're searching, we get a negative value. If the thing that we're looking for does not appear, then we know negative means we couldn't find it. So we know that. I can say lastIndexOf, which if I go, again, looking for years, it should return that -1. If I go looking for 4, what's the last index of 4? Well, 4 only appears once, and it's in the index 0 location, so it's not in there at all. But let's say I added another element to this list, 4 and 7, 4, and I go looking for, hey, where do you find the word 4? And I Google it, we should get that it's in location 4. So contains, indexOf, lastIndexOf, also useful tools for you. The next thing I want to talk about is how do we compare arrays and array lists? What's better? Do you use one all the time or the other? And to that I respond, it depends on the job you want to do. Certainly, declaring an array list and filling it is a little more cumbersome than the shortcut, right? So if I just had this array list right here, I could make a comparable array by making an array of strings. I'll call this more words. Except I gotta spell more words equals, and then I remember I can use that shortcut to initialize. I could say 4 and 7. Okay, 4 and 7. And now I've accomplished everything I wanted to do, right? So if I went to print out, if I went to print out arrays.toString of more words, we should get the exact same thing. I'm printing out words here and more words here. And if I did it right, they look exactly the same. So this is what it means for it to be equivalent. So one of the advantages with arrays, I think it's easy to initialize. I also think that access and assignment are pretty quick, right? If I need to go get an element, I just say more words, more words of 2. And if I need to assign a value here, a new value, I can do so. If I need to refer to it in an expression of some kind, I think it's pretty quick and easy to get to. To do the equivalent thing here, I would have to say something like, if I wanted to replace the index2 value with new value, I'd have to say words dot set index2 the value new value. So it's not appreciably more characters. We do use a method to do it. I think that some people will see the array technique is better here. Some will see the array list method better here. So we'll call that a push. So that's one comparison. I would say the primary thing that sets them apart is that the length of ArrayList is flexible. You know, if I wanted to add a fifth element, if I wanted to say words.add fourscore and 7 years, and 7 years, yep, ago, well, that's easily done. If I want to add more elements here, I guess we could say I could just add the next element as a part of the initialization. But what if it's later on in the code I realize that I need to increase, decrease the size of my collection? Well, there it is that arrays really fall short. So if you have something of fixed length, go with an array. If it's variable length, go with an array list. The last thing I would say is the way that they interact with primitives really differs. So let's talk about the advantage of ArrayList is it has flexible size is really its primary advantage. Let's compare two arrays of numbers. If I said I want an array called pi, this is always the example I like, and I'm going to fill pi with 3 and 1, 1 and 4. Well, that's my array of pi. If I want to do something equivalent, you might think to yourself, well, I'm just going to say ArrayList of int, and I'll call this pi2. I'll call it pi2 equals new ArrayList of ints. And we recall we have to open close just like we're doing a constructor. And I go, look, it's not compiling. And when I hover over, it says insert dimensions to complete reference type. And what we're really talking about here is that ArrayLists do not work with primitives. Primitives. Yeah. What does that mean? Well, obviously, we're going to want to be able to have collections of integers and decimal numbers and true-false values. What do? So insert, we have 4 wrapper classes I'll introduce you to. So we have integer, we have double, we have Boolean, capital B Boolean, and we have character. And the way it works is they decided in Java what they wanted to do was take individual primitive values like the number 3 or the letter K, and they want you to be able to have an object equivalent, a non-primitive version of those values. And previous in this course, we've actually seen some of these classes in work already. I think integer.parseInt allows you to take an int, like the int 32, and it turns into an actual int, right? I could say int converted. And what that did is it took the string 32 and made it to an int. So we've actually seen these classes before, but we've never made integer objects. And so what you can do, I'm fairly confident you could say like new integer. All right, doesn't this work? Please work. Yes. All right, good. So if you wanted to, you could construct it like you would construct any object, right? You can say the type, which would be integer. The identifier is I. Equals is the assignment operator. New means I'm using the constructor. What kind of thing am I constructing? It's an integer object, right? It's got to match this. And then as a parameter, you just feed in whatever value you need. So currently I holds the number 2. But they recognized in Java this would be really cumbersome if I wanted to make an object equivalent of the number 2, and it took me all these characters. So what they did is they said, you know what, let's just allow people to assign a value straight away. And what I'm doing now is the equivalent of the code that was just on the screen. And this is what we call boxing. And boxing is where you turn a primitive into its wrapper object equivalent. So it's not just the primitive value 2, it is the integer value 2. And it comes with it all of the methods and fields and any other qualities that an object might have. If you did this the other way, if I think, well, actually I should have tested this code before the video, but I think I can say int x equals new integer 3. Does this work? Maybe? Haha! Yeah, that's what I thought. Okay. This is called unboxing. It's where we need to take a complex, non-primitive integer 3, and we need to store it in a place that's meant for primitives. So this is take primitive out of its object, so that you can use it, right? So we have these wrapper classes, and what this means is if I wanted a collection of these numbers, I would not say int because array lists don't work with primitives. I would say integer. And then all I got to do now is I can say hey, pi2 dot add, and then we'll say 3, and I want to do commands like this 2 more times, and we would say 3, 1, 4. And what it's doing is it takes, so I think that's a literal int. It takes that int, it boxes us, converting it into an integer for us, and then adds it to the list. So if I printed out pi right here, if I printed out pi2 right here, we should get the exact same values. So in summary, this means if I want to use a primitive value in my array lists, I must wrap those primitive values in their appropriate wrapper class. If I want a collection of trues and falses, I need a capital B Boolean. If I want a collection of individual letters and numbers, I need a capital C character. And the reason is array lists should be our first example of something called generics. Generics is the term we use in programming to say when one class is designed to work with another class. We specified the angle, the inequality sign when we said integer right here, was us saying, all right, so array lists don't just stand by themselves. Array lists are meant to work with another class. What is it an array list of? It's an array list of strings. It's an array list of integers, whatever. So you're going to see other classes in the future that when you declare them, you have to declare what type that they work with. Stacks and queues are great examples of other classes that use generics. But our first example is going to be integer. And that is what I've got. Thanks for watching.